I have the top of the hour. It is 12 o'clock on the dot right now. So why don't we go ahead and get started with some welcome and housekeeping items as everybody keeps trickling in. So welcome everybody. My name is Jennifer Lee. I am a project manager and environmental scientist with AECOM. I am also a board member of the SAME Mid-Maryland Post this year, serving as the young member chair. The Society of American Military Engineers' mission is to lead collaborative efforts to identify and resolve national security infrastructure related challenges. If you'd like more information on becoming a member of SAME or to request a PDH for today's webinar, please contact us through our website that you can see on our slide here at same.org/mid-Maryland. Now, I've provided a quick snapshot of some of our upcoming events on the slide here. Please take a note of the last item here, which is our annual scholarship golf tournament. Please save the date for October 15th and stay tuned for developing announcements and information on that coming out. Now, as you know, COVID-19 has put a significant crimp on our planned events this year. As such, our post has decided to temporarily transition hosting our educational events through video conferencing. We are very excited to host what is our 7th webinar, I believe, at this point for the year with AECOM, who will be discussing the topic of PFAS, emerging contaminants, and evolving concerns. Now, a few housekeeping items. If everybody could keep themselves on mute, that would be great. We had over 50 registrants for this event today, so everybody doing their part on staying muted will help keep things moving along. Please be advised that we are recording this session and we'll be providing a link to the recording to all attendees via the email you used to sign up for today's event. Now, we have a lot of content to go through today, but we do anticipate some time afterwards for Q&A. So I encourage everybody to use the chat function within GoToMeeting to submit your questions as the materials presented. Again, we'll circle back around to that and answer them at the end. So with that, it is my pleasure to introduce you to our speaker today, whom I've actually had the pleasure of working with for the past 7 years. Dr. Rosa Gwinn is AECOM's America's PFAS lead. With nearly 30 years of service, Rosa has provided DOD clients with her technical and project management expertise and represents AECOM's more than 15 years of direct PFAS experience. So without further delay, Rosa, welcome, and you have the floor.
Well, thank you, Jen, and it is likewise a pleasure of my own that I've been able to work with you for the past 7 years. So thank you so much for the opportunity to join the Mid-Maryland Post. Let's just move ahead to the agenda slide and we'll give people a little preview to what's coming. So, of course, we'll share a safety moment. I'm going to cover some PFAS fundamentals at the risk of possibly going over material that some of you probably are already familiar with. So I think it just gives us a level playing field. I'm going to talk about PFAS in general, how they were developed and some of the uses of PFAS in manufacturing and industrial applications. Then we're going to shift gears a little bit, talking about regulations and drivers, and more directly related to folks at the SAME level, management of PFAS at DOD sites, thinking about how they move in the environment, and just thinking about them in the context of other types of projects other than environmental. And Jen's going to share that materials management information with us. And then we'll speed on to the one water perspective, the concept that everybody learned in elementary school about water being a circuit and touching us in a lot of ways. So let's get rolling to the safety moment. This is a depiction of a program that AECOM and prior URS adopted called Foresight, and I'm just very fond of it. It had great results. So it's not really telling you how to be safe in a particular instance, but to have to change your behavior to improve safety. And Foresight boils down to 4 simple questions, easy to remember, and you tee them up whenever you feel like it. You ask yourself, what am I about to do? What could go wrong? What could be done to make it safer or avoid those things that could go wrong? And then how have I communicated that to my team? And if you keep that in mind, not just in the workplace, but honestly, I use it all the time at home. I think it will create a safer environment for you and for those who are around you because of the communication aspect. So next time you mow your lawn, next time you trim your hedges, think foresight. Okay, well, let's just move along to fundamentals here. And this little tree depiction of the PFAS chemistry is a way to remind us that PFAS is this simple term that has actually a pretty broad basket of meaning. So let's go ahead and cover some fundamentals. So, of course, basics, PFAS, what is the acronym? It stands for per and polyfluoroalkyl substances. And PFAS and the attention to PFAS has fallen under different nomenclature in the past. This is the current accepted nomenclature. It encompasses over 4,000 synthetic chemicals that are made for applications for us for better living. But the alkyl substance refers to being branched or linear chains of carbon. And those carbons, which of course are bonded to one another, are typically bonded to hydrogen atoms. But in PFAS, those hydrogens are replaced with fluorines. And if you look at the bottom, there's a depiction of one PFAS molecule, PFAS, and that has 8 carbons, each of which is bonded, those are shown in gray, each of which is bonded to 2 or more fluorine atoms, shown in green. And that creates this tail, a fully fluorinated tail, which is hydrophobic, doesn't like to react. And the way to think about it is that carbon-fluorine bond is very strong, and it's not very reactive because the the atoms, the molecule is satisfied at that end. Now that other end that looks a little bit like an alien probe is the functional group, and it is highly interactive. So when you create not just one molecule, but thousands or millions or billions of PFAS molecules, you can create a surface with them that functions as surfactant and that can resist thermal, chemical, and biological degradation because of the strength of those carbon-fluorine bonds. Next slide. So also, let's just tweeze out per and poly for those of you who might have not taken chemistry or your Greek roots for language class in a while. But per means every, So what that means is every carbon is fluorinated, is fully fluorinated. And poly, or some, poly means some or many, polyfluorinated compounds, some but not all of the carbons are fluorinated. And so if you look to the left, we've got our old friend PFAS, we just saw it. And on the right, we have a polyfluorinated compound, also with 8 chains of 8 carbons in the chain. And that little area that's has a little dash around it, molecule can break there, right? Because remember I said the carbon fluorine bonds don't like to be broken, but these polyfluorinated compounds do react, can react, but when they do, guess what's left over? That carbon fluorine tail, a perfluorinated product is produced, right? So these polyfluorinated compounds can lead to perfluorinated compounds, and they're often referred to as precursors. All right, next slide. So I know this looks like a rather well-organized spaghetti on your screen, so I apologize, but the reason I like to include this diagram depicting the PFAS family tree is to impress on everyone of the great complexity of these polyfluorinated compounds, of these PFAS compounds, and to think about them in a very in their very unusual or unique to us chemistry. So starting at the left, we have the large family of PFAS. We talked about having perfluorinated, so I'm just moving across these yellow boxes up on the top. And then we have some subgroups, the perfluorinated acids, and they have 2 kinds, the carboxylic and sulfonic acids. And if you look on the right-hand side of the diagram, there's sort of 2 columns of just, acronym city. And what those represent are the most commonly measured PFAS in environmental samples. It's not everything, um, but it's the most common. So, we have a very large family, and we're only looking at, really, some people call it the tip of the PFAS iceberg. It gets even more granular because there are three compounds we've highlighted in light blue, and those are the only ones that the Department of Defense is currently managing from a circular perspective in the environment: PFAS, PFOA, and PFBS. The two in red are the only ones that have a federally accepted health advisory limit, which is a non-enforceable drinking water uh, advisory for two compounds, right? So we've got this big family, and we're trying to grapple with everything, but we're really only obliged to focus on a few parts of the iceberg, which makes life now interesting and is makes the future even more exciting, right? Because things are going to change. All right, well, thanks. That's kind of our chemistry 101 part. Uh, let's just move along and talk a little bit about where PFAS are used in everyday materials. And this little circle on the left, pie, is showing you some of the applications of PFAS in your everyday real world contacts. So I'm not going to go through these in great detail, but you definitely have touched PFAS. You've probably touched some form of PFAS today in your regular life. So let's just go ahead and talk about where they were developed. So you can even look this up on Wikipedia, but in the 1930s, Teflon, which is a PFAS compound, was accidentally discovered in a laboratory and was found to have some very intriguing and attractive characteristics. And those early developments were applied to some of the biggest research questions of the day, including the Manhattan Project, and and then later in the 1950s, PFAS started to be introduced in some form into consumer products. And one item that most people are familiar with is the Teflon pan, which was actually developed in France by a woman married to a perfluorinated chemist, and she said, that would make life really helpful for me to have a nonstick pan, and there came the happy pan. So, and then in the 1960s, the DOD adopted aqueous film forming foam, or AFFF, for firefighting uses for these liquid pool fires where large releases of petroleum may have occurred. And we're going to return to that because for the DoD, that's a pretty significant use of PFAS. Okay, so let's move along. I've touched a little bit on where they were used. You saw the pie chart early on, but really the PFAS compounds in their very and varied and very complex variety of forms do appear in a lot of applications that are high tech, regular tech. I mean, your Gore-Tex jacket, hair conditioner, food packaging. Of course, I've mentioned the aqueous film forming foam, the application in the oil and gas industry, and of course in aerospace. So there's some high tech and regular tech applications of PFAS compounds that have introduced them into our everyday lives. They've introduced them into the environment through manufacturing or disposal, and they've introduced them into our bodies through contact and ingestion. All right, next slide. So if that food packaging contact ingestion kind of raised your antenna, I hope it did. I'd like to mention a few things that started to develop in our thoughts about PFAS. So the application of these great stain resistant, water resistant, non-stick materials, just we went bonkers as society, and it really has benefited us. And then there started to be some concerns about them, partly because the perfluorinated, as we mentioned, are so stable that they're chemically stable. So the EU kind of was the leader in focusing on concerns about releases of PFAS into the environment. In the 2000s, there was a seminal paper written in 2002 that indicated that polar bear blood contained PFAS. Human blood contains PFAS. If you look at the ATSDR website, you can look up the information about prevalence of PFOS and in blood serum of the U.S. population. So that could give you pause. I think that would give you pause. And we know that polar bears aren't firefighters. So how did it get to these polar bears? Well, this is the process of bioaccumulation in the environment and movement through the ecosystem. So what's going on now is very exciting. It has to do with changes in regulations, which are really unfolding. I often describe this as the road is being paved a millimeter ahead of us driving on it, because there's just all this information about PFAS in the environment that are driving the regulations, and public scrutiny is intense. All right, so where does that put us next? It puts us in the position to think about what could be possible PFAS sources for releasing these compounds into the environment, right? Not so much the manufacturing, which of course is a source, but also the application of aqueous film forming foam for emergency response or for fire suppression at refineries, for um, um, volatile suppression in metals plating. It's very common to use PFAS compound. It has been very common to use them. And then, of course, I talked about all of the regular products that we usually encounter with PFAS, our clothing. I mentioned waterproofing, waterproof boots, carpeting, stain-resistant carpeting. All of that stuff ends up in a landfill, and son of a gun if PFAS aren't appearing in landfill leachate. Every time you use something in your household that contains PFAS, it has the potential to make its way to the wastewater treatment plant. So PFAS compounds that might be in your hair conditioner or would have been in other types of similar products in the past, or wastewater that comes from an industrial process that contains PFAS, all make it to the wastewater treatment plant. Not necessarily a source, an original source of the PFAS, but a secondary source where those can be released into the environment, including by the application of biosolids. Because remember, what goes into that wastewater treatment plant, if it's PFAS, is very similar to what comes out of the wastewater treatment plant. It's complicated, it's interesting, it's exciting, but biosolids is another way to now introduce PFAS into the environment. All right, so let's kind of put our arms around this whole thing. And the next slide is a bit of a summary here. So I haven't discussed this explicitly, but because of their chemistry, perfluorinated compounds are persistent. Not all of them are persistent. Some precursors can modify. We talked about polyfluorinated compounds, but once they reach that perfluorinated phase, they can be very persistent. They bioaccumulate. We don't metabolize them, and they've been shown to be toxic. And I have a few notes about human toxicity across the bottom of the slide. I'm not a toxicologist. If folks are interested in more information about the toxicity, there are ample resources I'd be happy to direct people to. But suffice it to say that there's a concern about their toxicity, including at pretty low concentrations. They're very mobile in water, so once they get into water or groundwater, they keep going, and you can create some very long plumes, very narrow plumes, because they don't interact, so dispersion is low. I talked about regulations being variable, and yet they're also highly conservative. And it's because of this bioaccumulation. You need to protect at a very low concentration for this lifetime accumulation of exposure, but also to protect those most vulnerable. If you look in the bottom, you can kind of piece it together that if there's concerns during fetal development and breastfeeding, there's a vulnerable population for exposure. So I know that we've kind of grappled with a lot of this, but if you head your way all the way over to the right-hand side of the slide, there have been some estimates about the remediation of PFAS that are kind of make your eyes pop out like a cartoon character. I mean, $1 trillion in remediation, what does that really mean? And that was actually based on an initial estimate from the Department of Defense. And you need to think about it as a quote, all-in number. It's not necessarily the number to treat groundwater contamination, but replacement of fluorinated AFFF, to remove and clean equipment, to take care of their remnant issues in soil or groundwater, concrete or other materials, right? It's an all, and to replace the AFFF with a safer foam. So that's an all-in number. More recently, the DOD has been presenting a number of about $58 billion for the environmental remediation component of PFAS. Let's just say those are some big numbers, right? All right, so let's talk a little bit more about regulations, and that brings us to the next portion of the presentation. So, and I apologize for how tiny this little graphic is in here, but I'll talk to it, and then you can see where you can find it on your own. So let's talk a little bit about why regulations sort of unfolded, and part of it has to do with this comment I made about PFAS being highly prevalent. So let's focus here on the United States. And what happens is every 5 years, the EPA is required under the Safe Drinking Water Act to test our public water supplies for compounds that are not currently managed. And under this so-called unregulated contaminant monitoring rule, or UCMR, PFAS were tested in the UCMR 3 round, which is approximately 2013, 2016. And what that meant is that the UCMR looked at large water supplies, so that's water supplies providing potable water to more than 10,000 residents. And they tested for 6 PFAS compounds. Remember that chart where I had a whole bunch of compounds? So those 3 highlighted in blue plus 3 additional. And you can look up this information. You can look up this information from UCMR3 for your water supply if you want. Go bonkers, right? And what they found was that they were super prevalent, at least at some detectable level, and detection limits were higher during UCMR3 than they are now. And there was an estimate that about 100 million residents had PFAS in drinking water supply. I should mention the UCMR3 also targeted a handful of small water providers, so it's not exclusive for large municipalities. But even more alarming at the time, in 2016, 6 million US residents were found to have PFAS exceeding the EPA health advisory limits. I mentioned those earlier. The health advisory limit now from the EPA for drinking water, this is a drinking water number, is 70 parts per trillion. We're not talking parts per million or parts per billion, we're talking parts per trillion now. Right? And 22 states are currently regulating or managing PFAS at some level of guidance, and some of them are managing PFAS as low as 5 parts per trillion. And those numbers, if you look at how the states are managing them, do go down over time. Okay, let me zero in on this little micrographic that I included, and I want to just discuss it. So the blue dots depict not just UCMR3, but other measurements of PFAS in drinking water. Okay, so this is I just took the snapshot the other day. You can see the date on it's July 20th. It is a map that is developed by the Environment Working Group. And that group, you can Google them. You can Google EWG PFAS and you can find this map. It's interactive. And they post the information as they find it in publicly released documents. And at a glance, you might think, holy mackerel, what's going on? There's a few hot spots, like look at Michigan or North Carolina. But keep in mind, there's sampling bias. That's where samples have been collected, right? That's where they've been collected. So if we end up doing a better job collecting water all across the country, we might see a significantly changed map. The other dots, and I realize that the colors are difficult to discern, are for military sites. And because of AFFF, being a pretty significant source of PFAS in the environment, EWG is focusing as well on these military bases. Now, one other comment, I mean, EWG is not like AECOM, but like on their own, really kind of an activist consumer group. And so they have some highly calibrated concerns about PFAS in drinking water. And when you go to their site, you'll find out information. You'll find it interesting. And with everything that you read on the internet, you should approach with a grain of salt. But you can learn a lot about your community. Um, so anyway, EWG kind of gives you an idea that this isn't just sort of in a few pockets. It's kind of national, and in fact, it's global. All right, let's talk a little bit about this parts per trillion, though. So you'll see numbers bandied about and little, hey, how small is small kind of things. Jen and I went down a rabbit hole yesterday, making for sure that this 3.5 drops, and drop isn't really defined, is a good metric. But yep, sure enough, if you had pure PFAS and 3.5 drops in an Olympic-sized swimming pool, you'd be at the 70 parts per trillion level. So we're talking about very, very low concentrations, right? That are considered necessary to achieve to be protective in drinking water. So that's a pretty low number, right? And I mentioned the 5.1. So this 5.1 parts per trillion, it's tricky. It's so low. All right. So let's talk a little bit more about what's going on with the regulations. And don't get sucked into any details of text here. I apologize also for it being so tiny, but it's really intended to create a picture of a timeline where two things are happening. So on the left-hand side, in earlier time period, and we shared earlier time scale. So this is just about regulations. So as early as the 90s, really in the 80s, the EU was looking at protection of waters from PFAS discharge. And if you march through some of these details in 2002 and 2006 in the US and abroad, there was a definite focus on reducing the manufacturing of PFOS, one of the ones that we were talking about, right? And if you look under 2009, kind of zero in at the bottom little bit of text there, you can see that the initial health advisories for the EPA were set at 400 and 200 parts per trillion for PFAS and PFOA. Remember, I just told you that they're now at 70. Well, if you zoom across the bottom row over there in 2016, and you can see the relationship perhaps with the UCMR3 results, the EPA felt that 70 was more protective. In the meantime, between 2009 and 2019, and actually continuing, uh, states are taking it upon themselves to set their own PFAS standards. And there's a range of limits, and they vary, and they're for different media. States are selecting to manage PFAS uh, in a way that it makes the most sense for the prevalence of PFAS in that state. And it may have to do with drinking water, but there are other media that are of concern. All right. And then the last thing I want to point out is that in February 2019, so it's a year and a half ago, the EPA released their so-called PFAS action plan, and you can go look that up. And if you Google that, you can also see their most recent update, which I believe was released in August, I mean the first of this month. And we're going to talk a little bit about what that meant. But the EPA has embraced some action to look more fully at the variety of PFAS compounds, their toxicology, their prevalence, our ability to manage them, our ability to destroy them and regulate them and remediate them. And they are weighing all of that as they weigh the possibility of establishing a maximum contaminant level, or MCL, which would, of course, drive environmental cleanups. So that's kind of an important issue, is will there or will there not be an MCL? And I will say that in December 2019, and it's actually open for comment now, I think it's still open, it might have actually closed in July, is the so-called regulatory determination, or the first step towards establishing an MCL in accordance with EPA regulations, or I should say US regulations. All right, so there could be an MCL, folks, right? So let's take a little mini deeper dive into that EPA action plan. And I think I called out these items: regulate. So they said that they would in 2019 set a regulatory determination as a step towards an MCL, and that is under review as we speak. They're also going to look at other PFAS compounds and try and determine more information about them, right? Because right now they're looking at PFAS and PFOA and some of the others that have a little bit of toxicological information that's deemed reliable. In the meantime, they're not going to let down their guard. They're going to look at releases. They're going to consider whether the class of substances or some individual PFAS could be considered hazardous substances, which of course creates a regulatory change under CERCLA in particular, but also for RCRA compliance. They are including a handful of PFAS in the UCMR 5 sampling. That's the drinking water sampling I think I mentioned earlier. They promised that they would add PFAS to the toxic release inventory, and indeed added, shoot, I'm going to get the number wrong. I believe it's 172 distinct PFAS compounds that if you handle or manufacture them, your TRI reporting in January through January of 2021, so I think it's due in May or March of 2021, that TRI has to include PFAS within those groups that exceed a certain volume that you've managed. And then in the meantime, there's a lot we don't know. And the PFAS action plan is funding research into human health and ecotox, looking at fate and transport, looking at treatment methodologies, and looking at how the risks exist and how we need to communicate them. So that's usually more than I say about the action plan. So I better move along because we do have quite a bit of material. I mentioned that the 22 states have some form of PFAS regulation either in place, under review, and frankly, many have adopted the federal health advisories, which are not enforceable. I want to reinforce that. So if you want to know, hey, what's going on at your site? Well, let me step back. One other comment. So because the states are managing PFAS differently, you're going to have some funny situations arise. And I'm just going to make up a site that's right there at the intersection, you know, at the boundary of Michigan and Ohio. We saw Michigan had all those blue dots on it in the EWG map. Well, wouldn't it be weird if, you know, the PFAS concentration you have to manage in a groundwater plume in Michigan crosses the Ohio border and then suddenly different value applies? I mean, that's a little weird, and it makes it hard for environmental consultants. Actually, we've done this before, not for PFAS. So it's just something you have to manage on a project level, but it is sort of, I think it creates consternation in the public because they don't know what's safe if they're two different values. And by the way, it's not just those three compounds we highlighted earlier or the two, it's a variety pack. So in Texas, there's 16 compounds that are managed by Texas, what is it? TDEC. So anyway, what's my point? Okay, they're not only variable from state to state, these regulations and requirements and guidance, but they do change over time. And so I'm just going to mention very quickly that the best and I consider most reliable source for getting the latest PFAS regulations by medium is at the ITRC webpage. So that, you know, just a tremendous amount of work is done there to stay abreast of PFAS as an environmental concern. Okay, so we're going to have to manage that. What else are we going to have to manage? We're going to have to manage that the public isn't very happy. In many cases, the public is thinking, what the heck is in my water? If it's not just H2O, I'm unhappy. And I think we can all relate to that. Of course, there are those of us who know, yeah, that water comes out of our faucet. It's not deionized distilled water. It's not just H2O. right? But what you don't really want is to have something that you think is bad for you, or worse, bad for your children, in your drinking water. And there's some startling interactions with the public that could occur on a project you work on or in your own community. Um, it's a little hard to see, but over on the right-hand side, you don't want to see this on, somebody tagging you on Twitter with a picture of these two children holding up cards showing what the levels in their blood serum of PFAS are because they were tested. Or on the left-hand side, a child carrying a poster showing that the child's pet has PFOA, 31 parts per million, I believe, in blood serum. Right, that's a downer. But right in the middle, there's a couple of adults, and they're just simply PFASed off. They don't want that in their water, and so we have to be aware that there can be some emotional responses to PFAS. And I'll just make one last comment, and that is, I can't imagine any time more important than right now for everyone to have access to clean water, because the best method to protect yourself from COVID-19 is washing your hands. And if you don't feel like using your water, or your water is limited because you're having it brought into your home, or you don't have access to water at all, which is even more unfortunate, it's a problem. It's a public health problem. Now, I don't want to confound COVID and PFAS. I don't want to do that. But I do want to be emphatic about the importance of access to clean water. All right. Well, with that little soapbox moment, let's just talk a little bit about how we can manage PFAS. And yep, that's a little map there. Well, that's fine. Let's just go to the map. Super duper. So this is a graphic just pulled off the internet. It's the DOD webpage, and you can see this also at the U.S. Senate webpage, the Senate Committee on Environment and oh, what is it called? I'll think of it in a second. Uh, Environment and Infrastructure or something. So anyway, what this is a map of the United States showing Air Force, Army, DLA, and Navy sites. And I apologize for the dots being very small, but I encourage you to just go and look this up on your own. And what Jen and I tried to do was snag this little zoom in area of the mid-Maryland or mid-Atlantic at a minimum. And I think we all recognize that we live in an area where there are quite a few DoD properties. And as a consequence, there's a lot of attention regionally and locally on PFAS from military bases that are right here in our neighborhoods. All right. So just something to keep in mind when you think about how the DoD is managing or thinking about PFAS. And I have a link down there to that site, but suffice it to say, it takes 2 seconds to use the Google machine. PFAS DoD should pretty much get you pretty close. And I assume it'll be updated over time. So why is the DoD, this lucky winner here? Well, at the beginning of this presentation, we talked about AFFF, or aqueous film forming foam. And there's a little anecdote here I want to share with you. So in 1967, before the widespread use of fluorine-based AFFF, protein foams were used to put out fires that would occur, if aircraft crashed or whatever, liquid pool fires, big petroleum fires. And there's two things that are associated with what you want to do for that. You want the flames to go out, and you want the flames to stay out, right? You don't want them to burn back. Because in many cases, you want to be able to rescue people, and you don't want to put more people at risk. So in the an unfortunate incident where an aircraft carrier crashed, released fuel, and the fire was fought by the sailors on board that ship. 134 sailors were killed. I mean, 161 injured. That's a tremendous blow. It's just enormously sad. Incidentally, little fact: John McCain, former presidential candidate, was on the forestall. So at the time, so then comes into play this or into the universe, AFFF. And the AFFF, and just on the right is one anecdote of a pretty significant crash in 1978, and AFFF was used. Um, 4 people died in that incident. 4 people out of 200. So I'm just going to say, if you want to have your life or your loved one who's flying on an aircraft, you want their life preserved, AFFF is a darn good product because it puts out the fire and it keeps it out. So the DoD adopted it. And you know what? If you're going to use something like that, you have to train with it. And that, my friends, is the primary way that PFAS from the DoD use has entered into the environment. The training and the deployment of AFFF systems around aircraft in particular. All right, or air services. So how does that work? Let's talk a little bit about how that what that means. So again, this is lifted from the ITRC document. I have acknowledged it here in the bottom because it's just a really nice graphic for a conceptual site model. So you've got training or a fire truck that is spraying foam on a training site or a fire. That foam, which contains PFAS, touches the ground surface and it enters into the soil. From the soil, it can make its way to groundwater. It can also go via overland flow or groundwater discharge into surface water bodies. If that groundwater is ingested either by a human being or an animal in an agricultural setting, that groundwater could have PFAS in it and it could enter into your body through those methods. Of course, from surface water, it could enter into fish, invertebrates that are eaten by fish, fish that are eaten by people, fish that are eaten by birds, fish that are eaten by polar bears, fish that are eaten by seals that are eaten by polar bears, if I want to go kind of like that. So for your site, if you're working on a site, of course, you're going to have your own conceptual site model. This is more uh, conceptual conceptual site model. It's in general what you need to think about pathways. Oh, and heck, I didn't even mention air, but these foams are foamy and they can billow off a site. We were on a meeting the other day where somebody mentioned that they had a release of AFFF. It was a huge volume, and they had what they described as school bus sized blobs of foam flying off in the air and landing someplace else. School bus sized blobs of foam. So that's kind of interesting. Anyway, so that's why we're concerned from an environment perspective about PFAS, and it's why the DoD needs to manage conceptually where those releases may have affected materials. And I think I want to turn the floor over to Jen real quick here.
Yeah, thanks, Rosa. So Rosa's talked a lot already about the chemistry uses and sources of PFAS, and just noted about how AFFF and PFAS commonly enters into our environment. So I wanted to just get a quick note in here about how folks in the industry and DoD may have to manage PFAS from a bit of a practical standpoint. So from the environmental perspective, a lot of the materials that we would deal with on a day-to-day basis for any kind of site assessment that may need management includes waste derived from investigation activities, such as soil cuttings or purge water from a groundwater monitoring well installation. Now, while PFAS is not currently classified as a hazardous substance, like Rosa mentioned, each state is developing its own regulations surrounding PFAS. And not only is it by the media and by the actual individual PFAS chemicals, but it's also waste in general and how that gets managed and treated. So depending on your site, you may be allowed to discharge your IDW to ground at the point of generation or at that source location, or you might have to drum all of your waste for treatment and or incineration later. And this becomes even more complex at sites where you might have some commingling of other contaminants that actually are listed presently as hazardous. So as soon as you containerize that waste, the clock starts ticking for the disposal and off-site treatment of that waste. And that can become tricky with PFAS because many disposal facilities presently, because this is such an emerging contaminant, are just kind of saying no thank you. If your waste might contain PFAS, they're just not going to accept it. So it gets a little tricky with logistics and getting that under control. Also, from a management perspective, particularly with the DoD, many facilities are starting to accumulate stockpiles of AFFF concentrate. Now, as Rosa mentioned, AFFF is really good, and it's actually still the most effective firefighting foam for petroleum fires. And actually, we still don't yet have an approved mil spec for non-fluorinated foams. Regardless, many facilities are moving forward and making the switch from AFFF systems to other types of foams, such as high expansion foams, which are touted as not containing PFAS or PFOA. Well, this leaves stockpiles of AFFF concentrate that need to be not only tracked and managed, but also eventually disposed of in an appropriate way. And Rose is going to talk a little bit in a moment about some treatment options later. Now, for those not in the environmental assessment or remediation business, I did want to touch on how PFAS might affect those in the general AEC community and some things to think about as construction planning moves forward. Now, the knowledge of a site's history is crucially important to understanding not only what contaminants might be in construction soil that may get moved around on site and even off site for disposal or landfill, but also construction debris from demolition. We're finding that studies are showing that concrete actually acts as a sponge for PFAS. So concrete that's been exposed to AFFF in particular could act as a continuing source of PFAS to the environment over time. That PFAS that's absorbed to that material has the capacity to leach out of it into whatever the surrounding environment is. So that's of particular concern for any kind of demolition activities and also the disposal of those materials offsite. Might be moving that contamination around. Now, there are methods in place to help us understand a site prior to commencing with any kind of construction activities, such as preliminary assessments or baseline studies. But because PFAS is so new and historically, nobody's really been tracking it. It was considered benign. It was not a hazardous substance and is not currently a hazardous substance as classified. So it hasn't been tracked over time. Uh, so our current tools don't yet have PFAS as a standard contaminant of interest in their methodology. In fact, the AST methodology for some of these types of assessments doesn't include it as a standard. Also, one of our other tools is Environmental Data Resources Reports, or EDR reports. This is a common tool that gives a little bit of historical information about a particular area. You can also get historic aerials from EDR reports. A very common tool. Recently, they have started including PFAS in their radius searches. However, that search radius is only a half mile around a facility. And as Rosa touched on a little bit earlier, PFAS are very mobile in groundwater. So these plumes in groundwater are very far reaching. So while it's possible that a particular site may not have any soil or kind of above ground impacts of PFAS, it's possible that a worker might be exposed to groundwater that is contaminated with PFAS during any kind of trenching or excavation activities. So definitely pay mind to that. Also, any water that is pumped out of those excavations may have to be managed in a particular way so that you're not moving contamination from one source to another or from one media to another for that matter. Excuse me. Certainly, if any drinking water wells are going to be installed on site, that's also a consideration to think about. So to illustrate how historic land use can impact a site, I wanted to share with everybody a really quick and short case study of one of our sites that present day had some detections of PFAS in drinking water. However, the land use didn't indicate any kind of activities that would have been considered a typical source. Well, we took a look back at historical aerial imagery and found that, lo and behold, back in the 1960s, you can see on the left-hand panel here, there was an airstrip at this site, which could indicate the use of AFFF historically. Fast forward 14 years to 1974, we see that construction activities have started to occur at that southern end of that runway. And then decades later to present day, or 2017 for this aerial, there's actually no trace of the airstrip left. Nothing to indicate that to those on the ground that were doing the site assessment that historically AFFF may have been used there. Now, furthermore, because you can see so much construction has occurred at this site over time, and typically PFAS hasn't been tracked, and AFFF use hasn't been tracked over time, we have no idea where soil may have been removed around on site and where debris may have been disposed of, or how it was managed, really over the full 60-year time window that you can see here. So it can be a bit complicated, and quite frankly, site histories can be sometimes a bit like finding a needle in a haystack. But understanding the site history is very important to reducing the long-lasting impacts of PFAS, and particularly being able to manage materials at the site properly so that you don't move any of that contamination around to a new location. So with that, I think I'm going to give it back to Rosa to talk about the One Water perspective.
Yeah, thanks, Jen. And, I especially value that Jen was for sure focused on being able to put into the context of those who might be from the Mid-Maryland Post, some PFAS concepts that might come up for them. So anyway, much appreciated. With a little bit of time that we have left and ample time for questions, I think I was going to talk a little bit about this one water perspective or the concept of one water. Um, I think I mentioned earlier, everybody, even back to elementary school, learned about the water cycle, water as surface water in oceans and lakes and streams, precipitation, and so forth. But all of that natural water cycle actually touches human beings, certainly through our potable water, and moves through a one water cycle. So just like in nature, precipitation, evaporation, in the anthropogenic application, we may receive potable water. And that water is distributed to us for domestic, commercial, or industrial use. And if that water contains PFAS, uh, because the potable water is being extracted, let's say, from a source that has PFAS in it, then the PFAS, because of their nature, especially the perfluorinated ones, are going to be distributed through all these uses, right? And then it's also going to be um, returned to our wastewater treatment plants, either from industrial processes or even from your household. Okay, so those materials can enter into the wastewater treatment plants, PFAS being present there. They can be extracted into biosolids in part, but the wastewater treatment can also often be applied for beneficial reuse or groundwater reuse. Very popular, not just in Southern California, but in many countries globally. Israel is very focused on groundwater reuse. So, once you got it in your cycle, PFAS is in your cycle, is the idea. So let's just talk about a very simple application where you might not think about PFAS interacting across a variety of water types or, water streams. And that's in the next slide. Um, there we go. And it's a case study from a stormwater application. So this is at Selfridge Air National Guard Base. You can look this up on the internet if you wish. We talked about AFFF use, and these two blue circles represent approximately the areas where AFFF was applied to the ground surface, just like in that CSM I shared earlier. And son of a gun, if the stormwater from this site isn't really chock-a-block full of PFAS. So, I didn't have the stormwater system in my graphic before, but what's happening here is really super interesting. So, Selfridge Air Force Base, actually, a good portion of it, other than the runways, is below the water level of this adjacent lake. And as a consequence, the storm drains interact they're placed where groundwater can reach, sometimes below the water table is my point. And if there are gaps in the stormwater system, then groundwater can enter into the stormwater. So not only could water PFAS enter into the storm system, maybe at the bottom of a fire training area, there's a drain, but also you can get a fairly complex interaction of stormwater with groundwater back to stormwater, and managing that system in one place requires a, a different way of thinking about measuring where PFAS are, right? Because these flow pathways are a little different from what we often think about, and because it's a perfect tracer, but also it influences mitigation, because we don't want this to discharge to this lake. This is in Michigan. So yeah, interaction of stormwater and groundwater is just one little tiny window into this one water perspective. So let's talk a little bit more about water and what we can do about it. So I mentioned that there's this EPA health advisories. They're non-enforceable. There's no MCL yet, but there is a definite desire to not have PFAS in potable water. And so this graphic might take a moment to sort of wrap your brains around, but it's kind of interesting. So if you think about technologies for treating PFAS and you chart them for on the y-axis, the stage of their development from from quite experimental to more mature, and then across the x-axis, their practicality, where you can use them best for water. And that also has to do with them being used more or less, and their ability to remove PFAS. Okay, so that's the playing field. Now, each box shown has either a black or a blue box around it. And the technologies that have a black box around them are those that focus on absorption or separation. So if you have PFAS, you can remove them from your medium. So on the upper left, in situ foam fractionation can separate and in some cases concentrate PFAS out of water that contains the PFAS, right? So now, but scoot over to the right a couple clicks, or even up in the top middle, incineration. There is a belief that incineration can destroy many PFAS. Now there's a concern that some aren't being destroyed, but for what it's worth, incineration at the time, and to a certain extent still is, a destructive technology. Okay, so you can feast your eyes on the different types of technologies, and you can see that we have more separation technologies than we do destructive technologies. And wouldn't everybody want to have that silver bullet of a destruction of the PFAS compound, pure mineralization at the end of the day? And the yellow boxes are really just around those very most common technologies used, all separation, used to remove PFAS from drinking water. Reverse osmosis, nanofiltration, activated carbon, and ion exchange, right? But none of those are destructive. Right smack in the middle is a technology that is certainly dear to AECOM, and that is the technology of electrochemical oxidation, which is capable of destroying PFAS in liquid streams. And I was going to talk a little bit more about that in the next slide. So AECOM's developed a technology trademarked as DE-FLUORO, and it's a destructive technology based on electrochemical oxidation. We believe that its sweet spot is applying to low volume, high concentration, high PFAS concentration wastes. And in some ways, it may be very attractive to be used coupled with other technologies. I mentioned separation technologies being so important right now. So if you are able to separate the PFAS from everything else and get a PFAS-free medium shown in this little flow chart here, well, that goes on its merry way. And then that concentrate, that remediation-derived waste that is PFAS concentrated, would be treated by DE-FLUORO to develop a PFAS-free liquid waste. And my friends, that is what we are working on quite diligently. So, all right. Well, we're coming up at the top of the hour. I think I just have two more quick slides. One thing to think about when you approach the DOD, or if you're working for the DOD, is what kind of services might I need to evaluate PFAS? And rather than read through them, I'll just suffice it to say investigation to navigation of the regulations to treatment and management, left to right, right? And yeah, this is a global issue. The next slide is a depiction of where AECOM has PFAS projects globally. We've gathered our team around a global focus so that we can put our best minds from the whole company together on trying to figure out how we're going to manage PFAS as a society and help our clients to that end. So that's it. I'd be happy to take any questions and really appreciate everyone's patience with this presentation.
Thanks a bunch, Rosa. I'm taking a look at the chat and I don't see any questions in the chat. So at the fear of unmuting everybody, I am going to unmute folks, or you can unmute yourselves as well to speak up with any questions that you may have. So I have unmuted everybody. You may still have to individually unmute yourselves on your own machines to speak up, but we'll keep the line open for a couple minutes just to see if anybody has any questions. Okay. I'm not hearing any oh, I see a question pop up in the chat, or maybe a note. Oh, it's a thanks. Many thanks to Rosa for a very informative presentation from Gwinn.
It sounds like your cat might have a few questions.
Yes, unfortunately, I do not speak cat, so I cannot translate for everybody.
Well, that's all good.
I do apologize. I tried
Oh, no,
closing
no,
the
no.
door, and it seems to have the opposite effect.
Yep, I had the same thing happen right in the middle. When you were speaking, I had my own kitty. Okay, well,
Well,
folks, I know that I covered a lot of basics, so hopefully if questions arise, if you need to know where some of these resources we talked about can be found, and I'd be happy to share. And of course, Jen is always here
definitely.
to connect you to the universe of PFAS information.
Yep.
So yeah,
So
thanks.
Rosa, I just want to give a really big thank you to you from our post for sharing today's all your valuable insight and experience today. We appreciate your time, and we actually hope to see you on future SAME events, maybe at Mega Maryland. We'll see. Also, a big thanks to our attendees. As a reminder, we will be sending out a follow-up survey to everybody who has registered today, and that will also include a link to the recording of today's presentation. If you are interested in receiving a PDH certificate for this event, you are encouraged to contact us through our website at same.org/mid-Maryland. Thanks again to everybody, and please have a wonderful day.